Jai Hind student, this is the next unit of telemetry principle, and in this unit we are going to concentrate on the three main important topics of this telemetry principle, that are FM-FDM, TDM PAM and TDM PCM system. So, what is that actually? As I told you earlier in the previous lecture, that in telemetry system we are creating the data at the transmitter, then that data is going on the through channel, it is receiving at the receiver. In this complete process, actually at transmitter we are performing two things: modulation plus multiplexing. Why we are using multiplexing? Because at transmitter side there are n number of sensors. Each sensor are creating data parallelly, and that data is going to be shared to the ground station on a single channel. It means there are n inputs and one output, only one output. That is why we use multiplexing. Similarly, we have to send the data to the distant location, and to send the data to distant location it is required that signal frequency must be high, so that it can neglect the noise and the distortion created by the other atmospheric or instrumental conditions. So, that is why modulation is required. So, combinedly modulation plus multiplexing create a multiplexed system, and that multiplex system is the second unit of telemetry principles. In this unit we are actually going to understand which kind of multiplexing you are using and which kind of modulation you are using, and by combining both of them we are creating a multiplex system. So, as far as consideration here, consideration of multiplex system is came here, that our multiplex system are of two type. The first type is analog and second one is digital multiplex system. Now, what is the difference between them? When you are talking about the analog multiplex system, means in analog multiplex system your signal is in the analog form, means you have to use analog multiplexing technique and analog modulation technique. As you discuss in the detail of telemetry system part, telemetry principle lecture series, multiplexing is of two type: frequency division multiplexing and time division multiplexing. In frequency division multiplexing we are dividing the available bandwidth into various channels or into various users. Means if you have a 300 megahertz frequency band and 3 users are going to use, then you divide that 300 megahertz into the 3 users by simply giving them 100 megahertz frequency band, each one of them. In this process actually there is a wastage of you can say that bandwidth, because at a time a user can only use 100 megahertz frequency band, whether the total available range is 300 megahertz. So, in this frequency division multiplexing we are actually use it for that analog transmission only. When we are talking about the digital transmission, we use the time division multiplexing system. In time division multiplexing system, if there are 3 users, then we are going to take a frame of 1 second. In 1 second frame we are using that complete 300 megahertz frequency band for a single user for 1/3 second. Means we are going to divide that 1 second slot into the 3 users by just 1/3 second, 1/3 second and 1/3 second. Means for 1/3 second that complete bandwidth is available to the user 1, so that it can send the data on the maximum speed. So, in digital transmission we are going to use TDM. Similarly, when we are talking about the modulation part, AM, FM, PM are the genuine analog modulation techniques, whether PCM and other are the digital modulation technique. So, combining both of them, if we are using a frequency modulation and using the frequency division multiplexing, we are creating a FM-FDM signal, FM-FDM multiplex system. Similarly, if we are using a time division multiplexing with a pulse analog modulation scheme, it will create a TDM PAM. If we are using TDM with the pulse code modulation, it will create a TDM PCM system. So, these all 3 points are very famous in the university examination questions. Many times out of these 3 questions, 1 or 2 question will came into the university question paper. So, before starting that FM-FDM system, first I told you about the tell you about the FDM system. So, when FDM system is came into the picture, means you have n users. Each user is generating a analog signal, that is M1T, M2T, MNT. Now, what is going to happen? You have to transmit this different signals on a single channel. So, we have to create a combined composite baseband signal, which is MBT. How it is going to be created? We are going to use subcarrier modulator. Subcarrier modulator, why? In modulation process, actually you are also use this modulation process as a frequency translation procedure. Means, if your frequency lies in the range of f and you want to transfer that frequency into the f1 frequency range, then the simple procedure is just perform the modulation by using a subcarrier frequency of f1. Means, your M1T signal frequency is FA. That FA frequency is modulated with the F1 subcarrier frequency and we will get a S1T signal. That is a submodulated signal which change the frequency band of the input M1T. Similarly, we convert that M2T into S2T, MNT into SNT. Now, by using a summer, we will combine all these signals and get a combined composite baseband modulating signal. Now, we have to perform the modulation part. Means, this part is related to FDM. And in this part, we are using a FC, means carrier frequency, to modulate this MBT signal so that it can travel to the long distance. So, combinedly it will become a FDM signal. Similarly, for FDM receiver, you are getting the FDM signal ST. First of all, a main receiver. Main receiver is just reverse of the FM. Means frequency modulation. Frequency modulation, here we are performing the demodulation part. So, after demodulation we will get that same composite signal MBT, and that MBT signal is again passed through the band pass filter F1, F2, Fn. Why? Because for this line F2 or Fn are not required. That is why we are applying a band pass filter which will only pass the F1 signal. Similarly, for F2, for Fn, and after that we are performing the demodulation by using the demodulator with a subcarrier frequency of F1, and we will get the recovered back M1T, M2T, MNT. So, combinedly this complete system is going to use as the FM-FDM system, but here question arises where what is FM, because we discussed the multiplexing part, but we will not discuss FM yet. So, about the FM, what is FM? Basically, FM is the frequency modulation, because this is our analog signal or information signal. this signal is modulated by using this carrier signal. A carrier signal having three parameters: amplitude, phase and frequency. This part cycle from here to here, this is showing the frequency, the angle that is showing the phase, whether that maximum and minimum value showing the amplitude. So, when we want to perform the frequency modulation, how it is going to be performed? We can modulate only one parameter of carrier as per the instantaneous value of the message signal. Means this is the message signal, its instantaneous value will be taken and that modulate the carrier signal in the terms of frequency only. Means the amplitude and phase of the carrier will be constant in this procedure. So, here you can see that in this process, this is the modulated signal, FM signal, and you can see here in FM signal, here frequency is low, whether here high, again low, low and high. Similarly, you can see that frequency of the carrier is changing and that change is as per the instantaneous value of the message signal. So, in the term of equations, if the CT is A cos omega CT, MT is AM cos omega MT, then the FT signal is A cos omega CT plus KF integration MF dt, where MF is the modulation index of the frequency modulation, which is the ratio of deviation with the carrier frequency, and that MF is actually going to show you the amount of modulation in the process. So, combinedly in frequency modulation, what we are using? The FM wave is comprised of an infinite number of sideband. Component bandwidth of FM signal must be wider than the AM. This is all about the modulation, frequency modulation. So, combinedly the FM-FDM multiplex system is here. In this you can see that this part is related to the multiplexing, this part related to the modulation, and all the steps are as per the previous one. You can see here low level signal, strain gauge, temperature comparator, MV range, all that means these all are the sensors. The sensors input are applied to this subcarrier oscillator part. So, here you can see that this is subcarrier, because here subcarrier, because we are using a calibration and we required a subcarrier frequency to locate the frequency into the desired range of multiplex signal. So, again here it is a SCO part, subcarrier oscillator, where here what we are doing, the same as I told you in the this part, this complete signal that is showing here. Now, after that we are taking the F1T, S1T, S2T, SNT, and that is applied to the linear mixer. Means here we will get a multiplex signal, FDM multiplex signal. Now, this FDM multiplex signal is applied to the FM modulator and FM transmitter, where this multiplex signal is going to be modulated by using frequency modulation, and here we will get a FM-FDM signal. Here that SC stand for the signal conditioners, calibration, and SCO for the subcarrier oscillator. So, this is the complete part of FM-FDM multiplex system. Similarly, this is the receiver part. In receiver, you are first going to perform the demodulation using the FM demodulator, then the demultiplexing. This is the demultiplexing part, same as per the this diagram. You can see that these are the band pass filter, demodulators and analog output. Similarly, now we are going to concentrate on the PAM and PCM part. Means pulse amplitude modulation means we have a modulating signal, now carrier is a pulse, and by using both of them we are creating the pulse amplitude modulated signal, in which this is the natural PAM and this is the flat top side. So, by combining this PAM system with the TDM, you are going to create a TDM PAM multiplex system. How it is going to be converted? You can see here. This is the part. This is related to TDM PAM transmitter part. Here you can see that these are the message input, means sensors input. Sensor 1, 2, 3, 4. Now, TDM, in TDM process, what is going to be actually done? You are actually performing the sampling. And for the sampling, as you studied earlier in the previous lectures, that in sampling you are following the Nyquist theorem for the sampling process. Because if you are not taking that Nyquist theorem, Fs is greater than twice of Fm, means if the message input frequency is Fm, then the sampling frequency should be greater than or equal to the twice of message frequency. Means if we are using a 3 kilohertz message, means sampling frequency should be greater than 6 kilohertz or 6 kilohertz. If that frequency, sampling frequency is less than 6 kilohertz, there is a problem of aliasing, means overlapping or distortion. To avoid that aliasing, we use anti-aliasing low pass filter before applying that for the sampling or the commutator part. Now, this commutator, that commutator is the main device of TDM system, in which a commutator switch, rotating switch is applied here, and that switch is controlled by the analog signal and pulse signal, and that pulse is actually related to the sampling frequency. So, when the sampling frequency will come as per the frequency, this commutator will going to change its position and one by one to the all number of inputs, and by that we are getting a frame. You can see here there are 3, means if 1 second means 1 by 3 second ये यहाँ connect रहेगा, then 1 by 3 from here, then 1 by 3 from here, and you are getting the TDM frame output at this pulse modulator. Now, here you can see that if this red line is showing the A signal, blue is B, green is C, and D is the straight line. You can see here, when we are performing the pulse part, pulse modulation means pulse amplitude modulation, these are the samples for the C, you can see that by this green. Similarly, these are the samples for the red, yani A, and for the blue, that are black and blue, and similarly black for this. So, combinedly they are creating a composite signal here, and that is giving us the TDM PAM signal. Now, that TDM PAM signal will travel through this communication channel. Now, after communication, it will reach at the pulse demodulator part. Here, the complete reverse process of this transmitter will be done. How? First of all, we demodulate the pulse PAM signal. For after demodulating, we are using a decommutator switch, and by this we will get the low pass filter, reconstruction filter, and we will get the users 1 to n inputs. So, the main point is, whenever a question will be asked in the university about the TDM PAM system, first of all you make this diagram, then you explain the TDM, then you explain the PAM, and then combinedly you make a TDM PAM multiplex system. So, this is the complete part about the TDM PAM part. Third one is PCM, in which we are actually using TDM with PCM. So, what is PCM? Actually, PCM is also known as analog to digital conversion, because in PCM actually you are applying an analog signal here. That analog signal is converted into the digital data in the form of 1100 110. So, how it is going to happen? You can see here this is a continuous signal, whether this is a discrete signal. So continuous signal, when you want to convert that into the discrete one, the first technology or first process phenomena is sampling. Sampling is a process of converting the continuous signal into the discrete one, and that sampling follow the Nyquist theorem, sampling theorem. That sampling theorem, as I already told you about, Fs is greater than twice of Fm. Then what we are going to do? We are performing the quantization, means quantizing. Actually, when we create the samples, these are the various samples, but our available amplitude range is a fixed range, and we have to characterize these all different sample in some categories. For that, that complete available amplitude range is divided into various levels, and that levels are defined as per the number of levels is equal to 2xm by del. Del is the step size, this is the step size, or that is the number of levels. 2xm is the complete frequency range, means plus xm minus xm for the analog signal. So that is the complete amplitude range with the step size. So that will create number of levels. Now that L levels are going to assign to various samples by just comparing the sample with the nearest available level. And in this procedure, if some sample is not just appropriate to the required level, then that sample will be rounded off to the next level, and that level is assigned to the sample. Now third part is encoding. In encoding process, what we are doing? In this encoding process, actually these number of levels are going to assign various codes, means to the power nu is equal to L, means if there are 8 number of levels, then 3 bits means nu is equal to 3. 3 bits are going to use to encode these number of levels, and as per the 3 digital units, that starting from the 000 to 111, means each level is having a different code of as per this 3 bit arrangement. So this is about the number of levels, number of bits relation. So this is pulse code modulation part. Now TDM PCM system, you are taking that PCM system with the TDM part. So how we are creating the TDM signal? Again the same procedure as per the previous TDM PAM system. Here you studied about the commutator, same here. This is a commutator or sampler, same thing is there. That sampler is connected with the n number of channels which are coming from the various sensors. That data came to the sampler, and the sampling switch is going to change its condition through the sampling frequency, and the changing position will create samples. That samples are then quantized and encoded, and we will get this signal, and that encoded, this is the sampled signal, encoded 101011 signal, type signal, digital signal is applied to the channel. This channel will send that data to the location next, and here this is the receiver part. Here decoding is going to be done. In this decoding procedure, again that decommutator switch, and this is the complete TDM PCM system. Sometime in the university examination, they ask about the only PCM system. So I am also going to cover that PCM system. In this PCM system, you can see here there are various blocks, and they are converting a combined PCM TDM system. How? This one is the one PCM transmitter from here to here, here to here. How it is going to be done? you are getting a analog input signal from the sensor of the range of frequency of 1 to 4 kilohertz. That 1 to 4 kilohertz signal is applied to first of all anti-aliasing filter to making the necessary condition true, that is Fs is greater than equal to twice of Fm. Now that Fm signal is applied to sample and hold circuit. In sample and hold circuit we are applying a sampling pulse of 8 kilohertz because here our signal is 4 kilohertz, here it is for 8 kilohertz, means just Fs is greater than twice of Fm. Then we are getting a PAM signal, sampled signal. Then PAM signal is applied to a analog to digital converter, means PCM part, in which quantization is done and encoding is done. For quantization we have levels, number of levels, total amplitude range upon step size, where for encoding we are using L is equal to the power nu. So at this point let us consider this sample. For this sample we are taking a 4 bits and we are getting 1011 code. So here you have to understand one point very clearly. For a single sample, this system is creating data parallelly, means as soon as one sample came into the picture, after the conversion we will get a parallel code of 1011. But when we are going to transfer that data on a bus, on a channel, that data will be transferred serially, means 1 after 0, then 1, then 1. Means you have to convert this parallel PCM code into the serial data, serial code. That's why a parallel to serial converter will be used with a line speed clock of 128 kilohertz. After that we will get a serial data. Similarly for the another channels the same point is here, and by combining all these inputs we are using a TDM multiplexer and we are getting the TDM multiplex output. So for TDM PCM system you can understand here one point very clearly. What you are going to do? You are actually combining the various signal into the one part. So as far as its main consideration is there of the second unit of the telemetry system, our main aim is multiplex system, means actually we are creating a multiplex system compatible with the available telemetry system. For that we are actually using various modulation as well as multiplexing techniques. In this same procedure we use this FM-FDM multiplex system with the arrangement of analog signal processing, because for analog signal we are using FDM and FM. For performing the FDM we are using the same FDM frequency modulation part, but with the subcarrier frequency. That's why we use here the subcarrier oscillator, and the inbuilt of subcarrier oscillators are modulator with the local oscillator. So this is about the FM-FDM system. Similarly when we are using a TDM system as multiplexing and PAM system for the modulation, we will get this TDM PAM multiplex system. And the third one and the most important part is PCM TDM system, which is I already discussed. So here you have to understand one point very clearly. Sometimes in university examination they ask a question, what is the role of synchronization in the telemetry systems? So here you understand one point, these all data are creating with respect to this 128 kilohertz clock pulse. Why? Because you are actually performing two things on the same at the same time at transmitter as well as receiver. If you are sending at T1 time bit B1 and at the receiver, if you are getting that B1 bit at another time synchronization, you cannot reconstruct the original signal back. That's why this synchronization is required for the proper demodulation of the signal. This part is also known as coherent detection. Means the transmitter as well as receiver both are in synchronization. So this is also another question which is quite many times asked in the university examination. So this is about the second unit. In the third unit, we will discuss about the modem specific questions. So till then, thank you.